Gatekeeper here. We got an Xforce straight 8 base plug in the wall, and it appears that this was either a straight 10 pill or a 2x8 at one point in time. You can tell where there was two extra transistors there. Could have been a straight 10. I'm not sure, but the guy has popped a few transistors, and you usually don't see this happen. But you can look down here and tell that this balancing resistor, this one, and this one are all gone. He's got 1, 2, 3, 4 transistors that have popped. I don't know how in the world that happened. Let's see, you got 1 transistor from this 2-pill section, 1 from this one, you got 1 transistor from each section. 1 pill from this section, 1 pill from this section, 1 pill from this section, and the last pill over here from this section are popped. That is, that's a first timer for me. I've never seen that before. But it happened, and it appears that the only thing I can guess is it got so hot over here that this came unsoldered. That's about the only thing I can think of. I might strip that back a bit and wrap it around there good after I replace this resistor. And let's see. One of the other things that I did notice in here that I think I'm going to change is if you look back here on this ground wire for the AC that's coming in, the earth wire there, or the ground, whatever you want to call it. It's you know, it's moving, as you can see, back and forth pretty easy. I think what I'm gonna do is just take that off and solder that wire directly to the board, so there won't be no question about that being on there good or not. And I don't know what's going on here. This screw right here is halfway off, and there's looks like a screw's been broke off right there, so I'm not sure if this board's been took out before and put back in. It appears that it might have been, so I'm not too sure about that. But it looks like this is one of the boxes that might have been one of the first PP100 boxes that Arlen done. Since just because I'm telling you, because of the case it's in, it's just why I'm guessing this. And so we'll get this straightened out for you, bud. I got a stack of PP100s. I'll kind of go through there and match out 8 for you. I'm just going to take all these 8 out. Since you got 1 per section that's gone like that, I'm just going to take these 8 out and look through my stack and just kind of match 8 of them for you, so you can have a matching set of 8 there, and get this bad boy back up and running for you. Alrighty, well, we'll be back. Alright, brother, we're matching up your output capacitors for each 4-pill section. It's 151. These are some real good high quality cats, man. These bad boys cost $5 a cat. There's your second one. Alrighty, brother, we got you all sewed up here on this end. As you know, I removed all 8 of these, and the problem that I was coming, actually, yeah, let's go ahead and put this on video. The problem that I was coming to was this right here. Let me get my atlas right here. Alright, let me hook up one of these transistors real quick here. Bear with me. Alright, these are the ones that came out of your box. Let's go ahead and do the test. Nah, that's not one. That is one that came out of your box. That's a blown one. Hold on one second. You actually had 5 blown ones. I said you had 4. Come out. Excuse me. After it's all said and done, you actually had 5, which is a record for me. All right, here we go. This is the transistor I'm talking about. All right, as you see, it shows up as a series diode network. Okay. All right, out of the 8, let's see. Out of the 8, 5 of them showed up as completely blown, which is these 4 right here. And then this one right here. Then 3 of them showed up as diode network, as I just showed you, series diode network. So pretty much to me, I don't really understand completely what that means. I don't know, maybe if the HFE value has actually gotten below 1. See, when we're looking at the HFE value, we're looking at a DC measurement of the transistor, which is not what we're using it for in this situation. But it's a good way to match your devices. Okay, so we ain't really looking at the HFE if it's higher or lower, if it does more power or not. That's just something that's kind of misunderstood by a lot of people. So I don't know, maybe if the HFE gets below 1, maybe it shows that on here, but I'm not sure. That's just something I don't understand right now about all this. Now, if I look at the transistor on a diode meter, the old style of looking at things, it actually shows good. But I dare not try to use one, so pretty much I had to replace all 8 of your transistors, and luckily I had enough. So anyway, once I changed all of that, all your transistors, I went ahead and put the 150s on and replaced all your resistors here that was blown, and new 10 ohms and everything. I was only getting power out of these 4 right here. That's when I discovered that one of the 4 transistor I had put in here was actually reading as the series diode network, and it was the transistor that was right here. So I pulled all 4 out, checked them again, and then replaced this one right here. So now it's up to good. It's up to par. It's working good now, man. I can't, of course, I can't promise how long it's going to work. I guess that's all about how hard you're going to run it. But the way they've got these switchers set up is they're 16.7 volts. I know that looks like a lot, but it is going to drop. But if you honestly ask my honest opinion, just me, I believe it's up a little bit too high. I would probably try to set it down to where it's going to drop to about 14.5 with these transistors. That's just my personal opinion, which, don't mean nothing but to me. I guess, and whoever else respects my opinion. But basically all these switchers are pretty much set to these two resistors right here. This is grounded to the board. So basically all 1, 2, 3, 4, 5, 6 of these, the regulators are tied to ground through these 2 resistors in series, which has it set to 16.7. Alright, so here's how we're going to work this. I got the driver hooked up, which is right here, which is 2 1446s. The old Gatekeeper 1446 2-pill. AB bias 2-pill I built for a buddy of mine that traded it back to me a while back. So we're going to be putting 2 1446s into it. And just to let you see Well, I got a 2500 watt slug in there, don't I? All right, we're basically going to be putting about 90 bird, okay? 90 watts RMS, 80 or 90. Let's say 80 or 90, about 200 PEP. That's about what we're going to be putting into it, okay? All right, this is what it yields RMS. We are on the 2500 watt slug. Get the focus. There we go, 2500 watt slug. Alright, so we're reading the top scale, okay? In between 5 and 10 is 750 watts RMS, okay? We're reading RMS. Alright, this is what we're getting with the bench radio, which is 4 watts. We're driving 4 watts RMS into the driver, two 1446s. This is what that yields. Yeah. Oh yeah. So it's right there about 600 watts RMS. Here's your PEP, top scale. Oh yeah. A hair over 1500 watts PEP. Here's your voltage drop. Ooh, 15.6 volts. Alright, what we're going to do now is hook up a hot radio and just give it a quick burp. I'm just kind of curious to see if we can get this thing up around 800 bird, just to see if we can do it. We'll be back. Alright, I've got the hot radio up, which is hooked up, which is going to be driving 8 watts RMS into the driver. So it's going to be banging the hell out of this driver. And let's see if we can't get about 800 out of this. I think we should be able to. Go! Oh yeah, that's about actually about 900. All right, just for the heck of it. Oh yeah, about 1600 watts PEP. So that's pretty good, man. She's performing good. I didn't see the drop. Let's see the voltage drop real quick. Ooh, 14.8. So it looks like they got it set up pretty good, but that is a pretty large drop from 16.7 down to 14.8, but I don't know if that's got something to do with the way they got it tied together like that to ground or not, but that's actually set up pretty perfect. It's hit the way that I was just driving it was pretty hard, and it looks like it's going to be running under a safe voltage, you know, once you put a little bit of drive in it. So that's set up good. Alright, man, well, she's working, and she's working good now. Pretty much 600 bird up to about 900. Just for the heck of it, we can put the 1000 watt slug in and get a little bit more accurate reading, or shall I say a little bit more of an eye-friendly reading. We got the 1000 watt slug in. Let's see what she yields on the RMS side of things. Oh yeah. Oh yeah. Yeah, about 850, somewhere around there. So she's working good. The driver's on 14.5 volts. All right, and we'll get the top put on this thing, man, and get this thing back to you, man. I appreciate you for being patient. I know you had to wait a little bit on this. I'm sorry about that. And just run her easy, man. I know been having a couple of people having a couple of problems, it seems, with the PP100s. I mean, they do the power. I mean, I've seen them. They do the wattage, no doubt about that. I don't know, maybe if people were just, maybe some people just hadn't really adapted to the Chinese approach yet. But, you know, all these Chinese transistors, HGs, DEIs, PP1, all, you know, all these type of transistors, man, we can't really run them like Toshibas like we really want to. You know, it's time to cut back a little, cut back on the dial a little, you know, adapt to the changes at hand. It sucks. All right, y'all. Oh, gatekeeper, everybody out there waiting on that preamp that's been in the making for about a year or so. Hey, it's here. It's here. All we gotta do now is produce a few of them. So the preamp is here finally. I'll be making a video of that soon. Old gatekeeper out here around the northeast end of Georgia. 73rds, God bless. And always remember, you can make peak watts, but if the bird don't line up, then you ain't really flying, and we good and gone. I just kind of made that up on the fly. We're going bye-bye.